Hello there, my name is Adam Wong, and today I'll be walking you through how to design magnet features for anatomical models. Magnet features can be beneficial for a slew of different applications. They can be beneficial for breaking a model into different component parts while preserving anatomical accuracy and alignment. They're also good for creating areas where you can open up the model and then clear internal supports from, and they also make for very flashy marketing models. Before we print a model like this, we recommend that you understand the limitations of your printer and material. For example, if you're working with a flexible material, we recommend that you print out maybe a smaller sample size before printing an entire model, mainly because if you're working with magnets and you're gluing the magnets in a magnet holder, or a feature that we'll show in this demonstration, you want to test the clearance that you need as well as the glue that you're working with, and that will save you time and money in the long run. With that, let's get into the demonstration. So as you can see here, we're working with Materialise Medical version 14. This is our final model here, and if you want to see the end here, we're going to be designing these three features here, these little magnet holders. Inside are magnets. If I show these three guys right here, these are the magnets that would be fitting into here, and they're the ones that we'll be working with for this demonstration are a radius of 2 millimeters and a height of 3 millimeters. To get started, let me show the initial model we'll be working with. So we'll have a model here, and let's say we want to make our cut, again, just right around the left ventricle here. In order to do that, we'll have to create a datum plane. I already have aligned a datum plane to the cutting plane here, but in order to create a datum plane, you just go to Analyze, Create Datum Plane. If for those of you with the Design module, it's under Design, Create Analytical Primitive, Create Datum Plane, and you would just select your points here, click Apply, and then go under the Align menu, and you could manipulate the plane as needed. So we have our cutting plane here. I'm going to go ahead and then I'll cut the model in half using Design Cut. Select our hollowed entity. Before I do this cut, we recommend that you duplicate this model because we're going to use it later on. And go ahead and hide our duplicate for later. I'll relabel this as Save for Later. I'll go ahead and hide that. So now we have our hollowed model here, and we're going to go ahead and again cut this model in half using our cutting plane. And the reason we're duplicating it and then cutting it here is because we need to show our where to align the magnets to and where that cutting plane is going to be. So now that we have our model here, I'm going to go ahead and hide our apex of the left ventricle here. So now we have a similar view as before. And now let's create our magnets. So the first thing in order to do that is we'll need to create an analytical cylinder. You can also do this under the Design menu, Create Analytical Primitive, Analytical Cylinder. I mentioned our magnets are a 2 millimeter radius and a 3 millimeter height. For this example, we're going to create double that height because we're going to have two magnets essentially. If you remember from the illustration, we have a magnet on this side and then a magnet on the other side. So combining those two magnets will give you a height of 6. So that will be our magnet cylinder. Go ahead and click OK. Underscore, let's label this as magnet. I'm also going to create another analytical cylinder, and I'm going to increase the radius to 3 and the height to 10. The reason being is we're going to add 1 millimeter in thickness radially and 2 millimeters of thickness longitudinally. Go ahead and click Apply, and I'm going to relabel this as magnet holder. So notice that our analytical cylinders aren't anywhere near our model. That's because we selected these 2-point method. It should be located at the origin. You can see our 2 analytical cylinders here. The next thing we're going to do is actually convert these to primitives. So if you go to the Design menu, Convert Analytical Part to Primitive, we're going to convert both of these to a part. So now I have our magnet and our magnet holder. What we're going to do next is align these. So I'm going to go ahead and plane to plane align under the align menu. And we're going to align this to the surface of our model. So if we go over to the surface, right where we made our cut, and you hover your cursor over here, and click somewhere on the surface, left click and hold shift. You'll give two options. We're going to select fit surface since we want to fit the alignment to the entire surface here as our fixed entity. And our moving entity, we're going to select somewhere on the top of the cylinder over here, using again that fit surface method. We're going to select our move along entity. So I selected the magnet holder's first surface entity. So I'm going to go ahead and hide that. And we're going to select our move along entity to be somewhere on the surface of our magnet here. And this is going to move our magnet along with our magnet holder. I'll go ahead and click apply. Don't worry about the analytical primitives. We're going to go ahead and just hide these for now. So now we have our magnet and our magnet holder. Let's show our magnet holder. I want to make our magnet holder transparent so we can see our magnet within our magnet holder. I'm also going to go to the align menu and translate our magnet so it's in the center of our magnet holder. We know that the surface over here is flush, and the height difference between this is a 6 millimeter tall magnet, and this is 10 millimeters, so we can just move this over 2 millimeters, and it should be right in the center. So we'll enable snapping and translation step, and we'll move this exactly 2 millimeters, so now it's in the center of the magnet. We're also I'm going to change the main entity of this translate rotate tool to our magnet holder and our move along entity to our magnet. And we're just going to move our magnet and magnet holder into this, move its center or centroid right into the center, or I guess the cutting plane. So let's move this over 2 millimeters. I believe it's 1 more millimeter away from being in the center. There we go. Yep. So it's right in the center now. And now that it's aligned in this plane, now all we have to do is align this magnet and magnet holder somewhere on the surface where you want to union these parts together. So now what we're going to do is go to again translate rotate. Again, it's under the align menu. Translate rotate. We'll select our magnet holder as our main entity and our move along entity. And now, as long as you don't move this in the blue direction here, we're just going to move it anywhere in the plane of the red and green arrows, or I guess the blue planar direction. And so we're just going to move somewhere on the surface here so that the union of the model intersects with the model here, provides enough legroom that the holder won't rip apart when you print this, and it doesn't intersect with the interior volume of the surface here, because we're concerned about preserving that surface. If you also want to check the other side, so let me just show the other side of this model and hide the blue side. And so now we're also not intersecting over here. That looks good. You may need to maneuver this around. So you might move this a little bit inward if needed. There we go. Okay, just hide this guy. And just notice that my move along entities were highlighted, so I'm just going to remove that and just do a couple Control Z's. So now that I'm just only moving my magnet holder. All right, so once you find a good position like this, all you need to do now is have our magnet holder here. We do need to do this 2 to 3 more times, because typically we would not want 1 magnet connection. We would want 2 to 3 connections at a minimum. I already went ahead and created 2 other magnet holders and corresponding magnets using the same exact process as before. And now what we do is we go back to original model, not our pre-cut model. So I'm going to go ahead and hide this guy and go back and show our save for later model. And now what we're going to do is Boolean union the magnet holder to the outer surface, or the entire model here. So I'll go to design, Boolean union, select our save for later model, our magnet holder, and then our other 2 magnet holders as well. Click apply. And go ahead and hide everything that is not our new model. So we should have a model that looks similar to this. You can turn on the transparency to see the interior, to see if you did any overlaps or anything like that. Should look good. And then from here, all we have to do left is cut the same operation we did before. So I'm going to go ahead and select our entity as our union entity. And our cutting plane is the original cutting plane. Click apply. Hide our union result. And so now we should have a model very similar to the one that you saw beforehand. If you want to see the results interiorly, you can hide this. So now, but remember, we still have to cut out our magnet holders here. So that's why we still have our magnets. So I'm going to go ahead and show our original magnets. So there's one. Show these guys. And so now all we have to do is subtract our magnets from the two models here. So we can go to Boolean subtraction. We'll select our union result 2 here, and subtraction entity is our magnet 2 and magnet 3. For this type size magnet, we typically run a 0.2 millimeter clearance, but again, this will depend on your printer and its limitations. We'll go ahead and click apply. We do have to do this for the other side, so I'm going to go ahead and hide this guy, and then select our union 1-001-1 as our main result. Give it 1 sec for the auto save. Select union 1 as a result. Our subtraction entity is the same as before, so magnet 1, 2, and 3. Click apply. And if I hide our, well, I can say leave our magnets, but if I'll hide this side, you'll see that we have, I can hide our magnets. You'll see that we have our magnet holder there. Same thing for the other side. And that is how you design magnet features for anatomical models. I hope you guys learned something today and have a wonderful day. Thanks for watching.